Hi, my name is Hector Caballero, and I'm a researcher at the Autonomous University of the State of Mexico. In this occasion, I am going to present the work Survey application for deaf-mute people based on IoT and cloud computing services, which was developed in collaboration with Diane Munoz and Marco Ramos. The structure of the presentation is divided into the following 6 points. 1. Introduction. 2. IoT and cloud computing. 3. State of the art. 4. Discussion. 5. Proposed model. And 6. Conclusion. In the world, there are currently more than 400 million people who have hearing and speech limitation. One of the disabilities, there are different ranges on the perception of sounds as well as the emission of words, being the most common condition of the genetic inheritance, problems in childbirth, infection, as well as the use of medication and exposure with loud noise source that damage the ear. People with this type of disabilities often experience situations of social exclusion. Any type of those limitation generates a series of problems that endanger this sector of the population, as well as living with restriction in society in access to services and sources of work, decreasing their quality of life. Traditionally, people with speech and hearing disabilities can communicate using sign language to be able to communicate in different environments. Sign language has the characteristic of taking elements in the expression of facial movements through the hands as well as the expression of written language. According to the Federation of Deaf People, there are more than 300 sign language. An important characteristic of sign languages is that it evolves with respect to the local needs of each region and each country in the world. Of the different types of sign language families are the following: British family, Spanish French family, German family, Swedish Finnish family, Indo-Pakistani family, Kenyan family, and Arab family. Currently, with the advance in computer science and electronics, both high-capacity algorithms for pattern recognition have been developed, as well as a small-sized device that can execute set algorithms to help a platform task in people's daily lives. One of the recent areas that applies the above is the Internet of Things, which is a process that allows connecting every physical element to the Internet to control whole house objects, medical devices, driving system, smart cities, among others. The basic architecture of the Internet of Things is composed of three basic elements, which are controllers and sensors, a gateway, and the internet connection. The information acquired by IoT devices can be processed by different applications, as well as accessible anywhere in the world by users who have the necessary permissions. Among the most important open hardware platforms that are used for the development of IoT projects are Arduino and Raspberry. This is due to their versatility and easy adaptation to different environments. This platform allows the incorporation of a great diversity of sensors, as well as obtaining an internet connection through Wi-Fi networks or cellular networks. In addition, these devices are capable of incorporating artificial intelligence algorithms to solve learning and communication problems, such as the translation of sign language to voice and text, and vice versa. On the other hand, cloud services allow to partially replace desktop applications since there are a lot of developments ranging from word processor, video, and images application, as well as advanced software based on neural networks for pattern recognition. The model of cloud computing includes software as a service, platform as a service, and infrastructure as a service. All cloud computing models include a rigorous security exchange because their violation generates problems of data loss as well as misuse of this. One of the main advantages of the IoT is that allows the incorporation of many sensors to obtain information in different environments, such as the acquisition of movements that are carried out in sign language, allowing to diversify the number of solutions that can be implemented in real cases. On the other hand, the software found in cloud computing can be executed from any point if there is a stable connection to the internet, avoiding the use of expensive licenses, being accessible directly through applications that obtain information from the server's main or web browser. But IoT and cloud computing concept can be combined to solve problems where high computing power is needed, as well as open hardware implementation. State of the art. Different investigations have been developed from the perspective of IoT devices and cloud computing to solve the problems that exist when communicating to people with speech and hearing disabilities. Several of these developments are based on the implementation of Raspberry devices to generate the translation of voice to an LCD screen as shown in Bayesian work. On the other hand, works can be observed that use acquisition of movements of the muscle or the movements of the hands to determine what type of sign language is being generated in the sign language to obtain the translation to speech and text as shown in Hessen and Baba and Bala. In other works, like HESDEC, they present a device that converts voice into a tactile signals with Morse code. In the work of Tavares, present work with the ability to detect risk in spaces for people with hearing disabilities. Due to the potential of cloud computing, there are several works dedicated to the translation of sign language, as is the case in Tavares' work, which use an advanced system based on chaos probability theory and SVD to analyze visual information. In Kim-Pong Lee's work, they use an holistic neural networks and machine learning to interpret the movements of the hands. In other work, in Shumilov's work, they develop an animation of movements with the hands to interpret captchas. In Galapali, they use convolutional networks with the efforts made to develop solutions that allow the incorporation of people with speech and hearing disabilities with cloud computing and IoT devices are varied. Due to the fact that there is a great diversity of both languages and sign languages, which require a different technical and scientific solution to be able to generate instruments with software as well as electronically to incorporate people into social and work life. The works presented in this analysis are experimental solutions due to the complexity of the problem of interpreting sign language into voice and text in its corresponding language, in addition to the fact that there is a general lack of knowledge on the part of people who don't present some type of speech and hearing disabilities with sign language. It is important to point out that not all disabled people have access to learning sign language due to the socioeconomic condition of each country. Due to the wide spectrum of solutions can be applied with IoT, it is possible to classify the different applications by the type of output that is produced. Translation of text and voice into sign language with images or avatars, translation of sign languages to text and speech. Among the most common proposals can be observed the use of voice-to-text and text-to-speech translators, thus with greater complexity can display images related to sign language, as well as the use of vibration system to alert user when a conversation or risk situation may arise. The use of communication networks allows to establish the sending of data with various equipment with Wi-Fi, Bluetooth, as well as the internet connection for data processing. With the versatility offered by open hardware platforms such as Arduino and Raspberry, it is possible to implement different technological solutions, among which stand out electronic gloves, speaker with microphone, and electronic solution in combination with mobile devices. The disadvantages of IoT are various, like intrusive with the end user, require a battery, and generally depend on stable internet connection. In the previous implementation, the ones that present the most complexity are those that allow to capture movements through mobile devices in combination with the sensors controlled by the IoT to reduce the degree of evasion present by using this type of devices with deaf-mute people. On the other hand, with the current development of cloud services allow combining the acquisition of information from IoT devices as well as smartphone to develop the translation of the gesture made by a deaf-mute person to be able and establish communication with other people. One of the biggest advantages of sign language translation model is that allow convolutional networks and other powerful artificial intelligence algorithms to be applied to classify the movements of individuals without a secondary device receiving the process load. Cloud computing services oriented to the translation of sign language are generally designed to the processing of digital images in real time for the interpretation of sign language, allowing the devices that are used to be less invasive with the end user. One of the main disadvantages that can arise when using cloud computing service is that the internet connection must be constant, which is difficult because the connection to Wi-Fi networks is not always guaranteed. Therefore, it is necessary to use telephony services to communicate data through 4G or 5G networks. Proposed model. In this proposal, it is chosen to use a video sign and language mapping software to establish the movements that have been made and perform an interpretation by voice and text. The analysis of movements will be executed in a cloud service so that the result is reflected in a PC or mobile device. The voice capture of other actors with the conversation of the deaf-mute person is processed by a Gaussian filter and SVD for the noise elimination. Then the information is sent to the cloud service and returned in the form of sign language that the deaf-mute person can understand, with the inclusion of a learning matrix that allows the model to learn gesture that the user needs or wise to incorporate its purpose. In the present figure shows a device that is responsible for monitoring the movements of a person through a camcorder that is mounted on a mobile device or a PC to generate the interpretation of movements. In this way, the translation of the sign language is generated in communication with an IoT device uh, with the function of monitoring stress levels to determine the mood of the mute person and thus generate feedback to reduce the level of stress or anxiety in the person. When stress events are detected on the system, tell to the user that must verify if any message in the conversation is not being understood to resume a fluid conversation. The advantage of incorporating the learning of sign language in the proposed system allows the use of language to be natural. Sign languages are constantly evolving as well as presenting new options to the user that allow them to reduce their stress levels. In this figure, the learning memory of the system is shown for the generation of the learning of new gestures, validating that the inputs are consistent and that data do not conflict with the inputs previously defined. And the proposal includes a quick response mechanisms for the identification of different voice frequencies to identify if there is more than one speaker in the communication, and thus indicate to the person with hearing impairment that there is more than one actor in the conversation. This model is based on the need to present solutions to people with hearing and speech disabilities, as well as providing the ease of adapting to the sign used by the deaf-mute person and which are not considered in the conventional sign language standard. This proposal combines the versatility of IoT devices to obtain biometric signals such as stress signals, as well as the power of cloud computing to analyze movements in real time. The most widely used hardware platform for conversion of sign language to text and speech and vice versa is Raspberry. These devices work with its own operating system for information control, use of sensor, the ability to use advanced graphical interfaces and communication with smartphones. Due to the use of sensor and other devices, IoT device can contribute to workload to devices such as smartphone and cloud services. The conclusion: the most widely used hardware platform for conversion of sign language to text and speech and vice versa is Raspberry. And these devices work with its own operating system for information control, use of sensor, the ability to use advanced graphical interfaces and communication with a smartphone. Due to the use of sensor and other devices, IoT devices can contribute to workload to devices such as smartphones and cloud services. Thanks for watching this presentation.